Hello again, Internet! I'm making this second Moppy tutorial video because the first one had at least one big mistake, sorry about that, and because there's been some improvements that should hopefully make this tutorial a little bit easier to follow along with and troubleshoot in case you run into any problems. Before we get started, two quick caveats. Number one, this isn't the only way to do this. You have other options for power supplies, microcontrollers, you can even replace the floppy drive with a stepper motor. But what I'm going to go through in the tutorial here seems to be the quickest way that I've found to get things up and running. The second thing is that I'm going to proceed very quickly through this tutorial as if everything works perfectly the first time, which is obviously not usually the case. The second half of this video will be some troubleshooting steps that you can go through if things don't work out for you the first time. Alright, let's get into it. Alright, first let's get all of our components together. You're going to need an internal floppy drive, and the kind you're looking for is the one with the 34-pin connector on the back there. There are some internal drives on older Macintosh computers and external USB drives that probably won't work using this method. You're going to need an Arduino Uno, or a reasonable facsimile thereof. You're going to need some wires to connect the two together. I'm going to use these little rainbow jumper cables, but any kind of wires should work just fine. And you're going to need a 5-volt power supply to power the floppy drive. I found that the easiest thing, if you've got one lying around, is to just use one of these ATX PC power supplies with the 24-pin ATX connector, mostly because they have these convenient little floppy drive connectors on the end of them. Now that we've got all our parts together, we'll start setting things up. We're going to start first with the Arduino. To set up the Arduino, you're going to plug it into your computer, and then you're going to open up the Arduino IDE, make sure all of your drivers are installed, and download the Arduino sketch, which you can find a link to in the description of this video, and upload it onto your Arduino. Now that that's done, we'll work on the floppy drive next. First we're going to take the power supply, and if you're using an ATX power supply like this, the way to turn these on is to connect the green wire here to ground, which the easiest way to do is just to use one of these black wires that's next to it. I'm using just a little piece of telephone wire here, but you can use any kind of little jumper between those two. Once your power supply is ready, you take your floppy drive and plug the power supply into the power connector on the floppy drive. The next step for hooking up the floppy drive is to enable the drive by connecting the drive select pin to ground. To do this, you'll have to identify the drive select pin. If you look at the connector on the back of the floppy drive, there'll be a key that indicates the bottom, and then the pins are numbered from left to right with the odd pins on the bottom. So this is 1, 2, mine's missing 3, 4, etc. On this drive, the drive select pin is pin 12, so I'm going to count 2, 4, 6, 8, 10, 12. Then I'm going to use a jumper wire to connect pin number 12 with the ground pin directly below it, which is pin 11. Once those two are connected, the indicator light on your drive should illuminate. Next, we're going to hook up the Arduino to the floppy drive. To do this, we're going to connect the step pin, which is pin number 20 on the floppy drive connector, to pin number 2 on the Arduino. We're going to connect the direction pin, pin number 18 on the floppy drive, to pin number 3 on the Arduino, and we're going to connect any one of the ground pins on the floppy drive to the ground pin on the Arduino. I've pre-labeled my pins on my floppy drive to make it easier for me to find them, but again, you're looking for pins 18 and 20, and any ground pin. So I'm going to use pin 19 just because it's close to the other two. Then on the Arduino, you're going to hook pin 20 to pin 2, pin 18 to pin 3, and the ground pin to the ground pin on the Arduino. Once this is all hooked up, you should be able to press the reset pin on the Arduino, and the drive will play the startup tones. Once you hear those tones, you know that your hardware setup is complete, and you can go download the Moppy control application from the GitHub repository and play some floppy drive music. Good luck and have fun. If things didn't work out for you on the first try, that's okay. That's pretty normal, actually. Here's a few troubleshooting steps that should help you figure out where your problem is so that you can fix it and get things up and running. Generally, I find when troubleshooting a setup like this, it's useful to narrow down the location of the issue by eliminating things that are working correctly. So we're going to go through a checklist and make sure things are working one by one. If when you press the reset button on your Arduino, you hear the startup tones from the floppy drive, then you know your hardware setup is working correctly. If you're still having trouble playing music, you need to troubleshoot the software setup on your computer. If you're not getting the startup tones from the floppy drive, we need to troubleshoot your hardware setup. The first thing to check is when you flash the Arduino sketch, pay close attention to the console at the bottom of the IDE. It can be kind of subtle sometimes when it has an error. If you're getting an error there, go ahead and Google that. There's nothing special about the Moppy sketch compared to other Arduino sketches, and hopefully someone else has had the same issue and has a solution for it. Next, we'll make sure that the power supply is working okay. If you're seeing the LED on the drive, your power supply is working fine. If for some reason you're not, double check and make sure if you're using an ATX power supply that you've connected the green wire to ground. You can usually tell that the power supply is turned on because there's a fan that will turn on, which I'm sure you can hear mine, or there'll be some sort of power light or something. If you're still not sure if your power supply is on, you can always check it with a multimeter to make sure that the red wire has 5 volts on it. If you're still not getting the power light on your floppy drive, double check and make sure that the drive select pin is connected to ground. Some drives may want you to use drive select pin A or drive select pin B. It's also possible that you have some sort of different adapter. So if in doubt, you can take a screwdriver and just carefully connect pairs of pins, odd to even, down the row until the light on your floppy drive turns on. So you'll connect pins 1 and 2, 3 and 4, 5 and 6, and just kind of work your way down until you figure out which one turns on the light on the drive. If the light on the drive still isn't turning on, it's possible that the floppy drive is bad. If you have a second floppy drive, try the other one. If you don't, it's also possible that the light is just burnt out. I do have some drives where the light doesn't come on, but the drive works just fine. Let's go ahead and continue the troubleshooting steps, and hopefully the problem is somewhere else. The last thing to check is the connection between the floppy drive and the Arduino. So once again, you're going to make sure that you have pin 20 on the floppy drive connected to pin 2, pin 18 on the floppy drive connected to pin 3, and make sure that you have one of the ground pins, one of the odd numbered pins, connected to the ground on the Arduino. If you're unsure which pins on the floppy drive to use, you can manually move the stepper motor by taking the pins you have selected. I have a ground pin here in my right hand, and in my left hand I have the step pin, number 20, and the direction pin, number 18. If I ground the direction pin, 18, and then tap the step pin, it's a little subtle there, but you can see that every time I tap, the drive moves forward 1 tick. If I disconnect the direction pin from ground and only tap the step pin, the drive will move backwards 1 track every time I touch the wires together. You can use this to try to locate the pins on the floppy drive if you're unsure what they are, or if you have a floppy drive that has an unusual interface. Once you verify that those pins are correct, you can hook them up to the Arduino again and give it another try. So hopefully after all this troubleshooting, when you hit the reset button on your Arduino, you are greeted with the startup tones. If for some reason you still can't get that working, you can comment in the video below or stop by the GitHub repository and ask your question there. Please include what you have tried and what is working for you so that we can more quickly narrow down where your problem might be and get you set up.
So, you've got a single floppy drive playing music. Now what? Well, one of the more obvious next steps is more floppy drives. The Arduino Uno can support up to 9 drives easily just by connecting additional drives to the Arduino pins in order. So the step pin for the second drive would connect to pin 4, and its direction pin would connect to pin 5, and so on. With only slight modifications to the Arduino sketch, you can support up to 16 drives, but you will need either a microcontroller with more I/O pins or a different configuration option in the sketch, both of which we'll talk about in just a moment. There are many viable alternative devices you can use instead of a floppy drive to generate sound. The signal from the Arduino to the floppy drive is essentially a square wave at the frequency of the note being played, so you could, for example, connect that signal via an amplifier to a speaker and hear the tone directly. The Arduino sketch also allows you to choose different Moppy instrument classes to support playing music on devices that might need a signal other than a basic square wave. There's a shift register instrument for simple on-off devices like a xylophone or drums, and an L298N instrument if you want to connect to an L298N stepper motor controller. While the Arduino Uno is an especially easy microcontroller board to get started with, you should be able to fairly easily use any controller that supports the Arduino framework. This includes, of course, other Arduino boards like the Arduino Mega, but also includes boards like the ESP8266. The ESP8266 in particular has Wi-Fi support, which allows you to play music from your PC to the board over a wireless network. In this video, I used an ATX power supply, which has the advantage of being relatively common and having a ready-made floppy power connector on it. However, the floppy drive, and the Arduino for that matter, only need a 5-volt power source. This means any 5-volt power supply with suitable capacity can be used. Each floppy drive probably needs somewhere between 500 milliamps and 1 amp to operate, though it seems like these values vary significantly based on your particular setup. When connecting the 5-volt power supply to the floppy drive, you can use the ATX connector as a guide, since the red wire will connect to the drive's 5-volt pin and the black wires to ground. There are probably plenty of other modifications that I haven't mentioned, but I'll let you suggest those in the comments and test them out for yourselves. I hope this video has been instructive, and of course, if you have any other questions or suggestions, stop by the GitHub repository and open an issue.